Good day, students. Welcome to another chemistry class. Our topic we want to look at this day is nature of matter. What is matter? Matter is anything that has space and occupy space. Anything that has mass and occupy space. What is the difference between mass and weight? Mass is constant, while weight vary from one place to another. Examples of matter include air, water, plants, and animals. Air contain elements like nitrogen, contain oxygen, contain carbon dioxide, noble gas. Water, the water body, river, stream, plants, different type of animals. Any substance around us regarded as matter, including ourselves. So which matter, anything around you can be regarded as matter. Air that you breathe in, the water around you, the plants, the flowers around, the animals, the domestic animals, goat, dog, etc. You can classify matter physically. Physical way of classifying matter in terms of their structure. Matter exists in different states as solid, liquid, and gas. Matter can be classified due to their structure, according to their structure, as solid, as liquid, or in gaseous form. Also, matter changes from one state to the other through some processes, and this will come about by change of temperature, as we are going to look at some of the examples here. Matter changes from one state to another. It can change from solid to liquid. It can change from liquid to gas. It can change from gas to solid. It can change from gas to liquid, depend on the change in temperature. For example, solid can change to liquid when the temperature is increased, and that process is called melting. In the same way, liquid can change to solid at low temperature, and you call that process friction, that is at low temperature. A liquid will freeze at minus 4 degrees Celsius, while a solid will melt, depend on the nature of that solid, from 100 degrees centigrade and above. Liquid can change to gas also when you apply temperature, and you call that process evaporation. Solid can change to gas directly, and you call that process sublimation. Not all solid can undergo this. We have some examples of solid that can change directly from solid to gas, and we refer to them as sublimates. Examples are ammonium chloride, naphthalene, sulfur, camphor, etc. They are the solid that can change to gas directly. Also, gas can change to liquid. You call that process condensation. Gas change to liquid. For example, if you are boiling water and you cover that container with a cover, when that water reach boiling point, remove the cover of the lid. You cover that the water begin to drop. That's the water vapor that change to liquid during the process of condensation. The last one is gas change to solid. Gas change to solid. You call that process a gas compresses. A gas compresses to become solid. Also, we look at nature of liquid based on what we refer to as viscosity. That is, this how thick a liquid is, we refer to as viscosity. Liquid is thick, e.g. honey, engine oil, they are more viscous than petrol. When you look at petrol, it's light. When you look at honey, thick. And also look at the engine oil. So you can see that engine oil and honey are more viscous, or they have more viscosity than petrol. Also talking about volatility, it's talking about their degree of evaporation. Volatility is referred to as degree of evaporation. Some liquid can evaporate easily than other. That referred to as their degree of volatility. Also, you can consider solid liquid gas, their properties, similarities, and their differences. For example, the solid liquid gas, all of them have fixed mass. And in terms of their differences, solid very dense, liquid less dense, and gas least dense. Talking about their density. Also, in terms of a shape, solid has definite shape. For example, the table depends on the shape of the table you are using. Some of them can have rectangle, or some of them can be in circular shape, depend on the how it is being constructed. The liquid has no definite shape, and gas has no definite shape. In terms of volume, solid has definite volume, liquid no definite volume, and gas no volume. Liquid cannot be compressed, solid cannot be compressed, but gas is compressible. Again, solid cannot be compressed. You cannot compress liquid, but gas is compressible. The last difference between the three, liquid, solid, and gas. Solid, the particle in solid vibrates, move about at a fixed position and at a constant speed, while particle vibrates, rotate, or move absolutely in a restricted area in the liquid. But in the case of gas, their own particles or molecules move about freely. That's why I said gas molecule move freely because of a little force that's holding them, compared to the solid that are being having a force of attraction between them, compact structure. Liquid move about in a restricted area, while gas move about freely because of this. The molecules there move constantly and randomly. That's what we have under solid, liquid, and gas. Also, we look at what we refer to as changes that occur in matter. Whenever a given substance is heated, that is, you apply temperature, its state changes, as we have discussed. When the temperature increases, solid will change to liquid. But when the temperature decreases or you reduce it, liquid can change to solid. We have discussed that solid to liquid, melting, liquid to solid, friction. So what brings about changes is temperature. Also, we have other changes that matter undergo, and we refer to as physical changes or chemical changes. Physical changes or chemical changes. A physical change is a change which is easily reversible, the one that you can get your substance back. No new substances are formed in physical changes. For example, if you dissolve common salt, that's sodium chloride, in water, you can recover sodium chloride through evaporation. You allow the water to dry up and you recover your sodium chloride. That's example of physical change. Changes in state of matter such as melting of solid, that is, you have your ice, it can become liquid. Freezing of liquid, that is, your liquid water can become ice. Also, your liquid water can evaporate to become water vapor. Also, you have some substances that can sublime. They change from solid to gas directly. Examples are what we have said. That's ammonium chloride, sulfur, camphor, iodine, etc. All these are examples of physical changes. Also, you have magnetic material that can magnetize or demagnetize, e.g., iron nail can magnetize, while sand will not attract to magnets. These are referred to as physical changes. Also, when you are separating your mixture, that is, when you have two compounds that mix together. For example, you have water and ethanol that become a mixture. You can separate this by a process known as distillation. Distillation, that is, you separate water from ethanol. Why? The two have very close boiling points. Water has 100 degrees Celsius, while ethanol has 78. When the two are together in a mixture, it can be separated using the method referred to as distillation. This is also an example of physical change. A chemical change is a change which is not easily reversible. You can't get your substance back. That's the meaning of not reversible. And in this case, new substances are formed. In chemical change, new substances are formed. What are the examples of chemical change? Rusting of iron or metals. Your iron nail, you look at it when exposed to moisture and air, that is water and oxygen, it becomes rust. That's an example of chemical change. Also, when you dissolve metals, sodium metals dissolve in water, will give you an alkali, that's sodium hydroxide. Also, when limestone dissolve in acid or react in acid, what is limestone? Limestone is calcium transcarbonate 4. Dissolve in any acid is going to liberate hydrogen gas. This is referred to as a chemical change. In the other way around, also you have substance decay or ferment. This is an example of chemical change. Chemical change, that is, you have glucose ferment to give you ethanol and carbon 4 oxide. That's an example of chemical change. There's no way you can return ethanol back to glucose. You can't combine the two. That's why it's an example of chemical change. Also, reaction electrochemical cell. Electrochemical cell, the cell where the chemical energy convert to electric energy. The changes there is an example of chemical change. Another example is when you add water to quicklime. What is quicklime? Quicklime is calcium oxide. You add water so calcium oxide is going to give you calcium hydroxide. So these are also example of chemical change. And the last example, burning of any materials. When you burn your paper, your wood, is going to give you ashes. There's no way you can return back to paper or wood. So basically, chemical change is a change that's not easily reversible. And you have new substances formed, as we have given these examples. Let's look at the difference between the two, physical change and chemical change. Physical change, as we have said, is easily reversible. You can get your ice back to the liquid when your ice is met. But in chemical change, it is not easily reversible. In physical change, no new substance form. No new substance form. When you have your ice turning to liquid water, in the same water, your liquid water also can be evaporated, become water vapor. Do the substance form. But in the case of chemical change, new substances are always formed. These substances are always formed. Example above, water added to calcium oxide. In that case, you are going to have calcium hydroxide. Physical change, there's no change in the mass. Whatever the mass you have at the beginning, what you are going to have at the end of the reaction. But in the case of chemical change, there is always a change in the mass of substances formed, as the case may be. While there's a reaction taking place. For example, now when you burn your paper, you measure the mass of your paper at the beginning, and you measure the mass of your ash at the beginning, it can not be the same. There's a change in the mass of substance form. Number 4, it does not involve any physical change, not involve any great heat. It does not involve any great heat, whereas in the case of chemical change, there is a great amount of heat is involved. So we have this major difference between physical change and chemical change. From there, let's look at how we can classify matter chemically. The first one we look at, you classify your matter into solid, liquid, and gas. That's physical classification. But in the case of the other one, you classify matter chemically. Matter can be classified chemically into elements, compound, and mixtures. Elements, compound, and mixture. What are elements? An element is a substance which cannot be split into simpler units by any known chemical means. An element is a substance which cannot be split into simpler units by any known chemical means. We have 118 elements presently. There are 118 known elements, and 90 of them occur naturally, while the rest are made artificial in laboratory. 90 occur naturally, while the remaining one are the ones that are produced in laboratory. Examples of elements are sodium, calcium, hydrogen, carbon, copper, nitrogen, oxygen, sulfur, fluorine, chlorine, magnesium, etc. Elements are arranged according to their atomic number, and they are grouped into metals, metalloid, and non-metals. Elements are arranged according to their atomic number. The arrangement of elements in a table according to their increased atomic number is referred to as periodic table. When elements are arranged in the order of their increasing atomic number in a table, that table is referred to as periodic table. In periodic table, we have 8 groups. That is, the vertical arrangement is referred to as group, while the horizontal is referred to as period. 7 periods, 8 groups. Periodic table has 8 groups and 7 periods. The group are the vertical arrangement, while the horizontal are referred to as periods. For example, we have group 1 to group 8. Group 1 to group 8. Group 1 to group 3 are called metals, while group 4 to 7 are called non-metals. Group 8 elements are referred to as noble gas, inert gas, or rare gases. While in between metal and non-metal is where we have metalloid. We have metal. That's why the elements can be grouped into metal, metalloid, and non-metals. For example, let's look at the example here, metals. As I've said, you can find them in group 1, sodium, potassium. In group 2, you have calcium, you have magnesium. In group 3, you have aluminium. And also, we have arrangement of elements between group 2 and 3, and that referred to as transition elements. We also have metals there. So the metal like iron, find the zinc, lead are what we have in that arrangement. The metals has physical property, just like it can conduct electricity, and also it can conduct heat. Metalloid are in between metals and non-metal. Metalloid are in between. That's why they said they are semiconductors of electricity. Semiconductor, as you know, metal, good conductor, non-metal, non-conductor. Metalloid are in between. They are referred to, they have conductor of electricity. Example, as I've said, in between, you have silicon, you have boron. Silicon is in group 4. Boron is in group 3. Arsenic, you have tellurium. So tellurium also in group 6 element. Also, we have non-metals. Non-metals, as you have it from group 4 to 7 is where you have non-metals. Group 4 to 7 where you have non-metals. Oxygen is in group 5. Chlorine, group 7, the halogens. Hydrogen, the element that's in group 1, but because it's a gas, a non-metal, it's only in that group 1 because it has one electron, the outermost shell. It's a gas and it's a non-metal. Also, we have bromine. We have bromine. We have bromine. Bromine is also in a group 7 element. Group 7 element, that's bromine. So that's what we have. Element can be a metal, can be a metalloid, also can be grouped into non-metals. Elements can be grouped into metals, group 1 to 3, or the one that are fine transition metals. The metals that are in between, while non-metals are found in group 4 to 7. When we look at this arrangement now, we have the first 20 elements. We have here their symbol and their atomic number. The atomic number here, the first 20 elements, the atomic number is just like their serial number from number 1 to number 20. And by the time you move further, after 20, from 21 to 30, that's you are talking about the first set of transition elements. After the first 20 elements, from 21 to 30, are referred to as the first set of transition elements. Elements that are in between group 2 and group 3. The transit, that's the meaning of transition element. Let's look at this arrangement. Hydrogen is number 1, atomic number of 1. The symbol is H. We are still going to look at how these symbols were derived. Number 2 is helium. He is the symbol. Atomic number is number 2. Number 3 element is lithium. Li. Atomic number is number 3. Beryllium number 4. Be. Boron number 5. The symbol is B. Carbon is C. Number 7 is nitrogen, N. Oxygen number 8, O. Fluorine number 9. Neon number 10, that's Ne. Sodium is Na. Na for sodium is derived from the Latin name referred to as natrium. Number 12 is magnesium, Mg. Number 13, aluminum, Al. Silicon number 14, Si. Phosphorus is P, that's number 15. Sulfur is S, number 16. Chlorine is Cl, number 17. Argon number 18, that's Ar. Potassium is K. K is derived from the Latin name, that's Kalium. Also, you have calcium, that's C, number 20. And from 21 now is where we have the transition element. So we have scandium, that's SC. 22 is titanium, that is Ti. And we have number 23, vanadium, that's Vn. We have chromium, that's a Cr. And we have manganese. Vanadium is letter V. Chromium is Cr, that's 24. Manganese is Cr, that's number 24. And number 25 is manganese. 25 manganese. And number 26 is iron, that's Fe. Fe, that's also from the Latin name we refer to as verum. 27, you have cobalt. 20, you have nickel, that's Ni. 29, you have copper, that's Cu. Cu also derived from Latin name called cuprum. And the last one there is 30, that's zinc, that's Zn. So that's example of the element. If you look at it now from number 1 to number 30. So let's also look at the next. When you want to classify element, we want to classify now matter, as we are discussing, as chemically. We have looked at elements. Now let's look at the second, which is called compound. Classification of matter chemically. The first group, elements, which we have discussed. Second group is compound. What is a compound? A compound form when two or more elements are combined chemically. A compound form when two or more elements are combined chemically. So which means a compound form as a result of chemical change. A result of chemical reaction between two elements. Two or more elements. So we have an example here. The first one is compound, common third. The element we have the sodium and chlorine, and the formula is sodium chloride, that's NaCl. The common salt, the name is sodium chloride. The element that are there, sodium and chlorine, the formula is NaCl. Second example of compound is water. Element you have in water, hydrogen and oxygen, the formula is H2O. Another compound example, caustic soda, that's the common name. The aliphatic name is sodium hydroxide, and the element there, sodium oxygen hydrogen. Caustic soda, that's the common name, and the aliphatic name sodium hydroxide. The element are sodium oxygen and hydrogen. Another example of compound is sand, and the name is also silicon 4 oxide. The compound, the element there are the element silicon, element oxygen, and the formula is SiO2, sand. The aliphatic name silicon 4 oxide, the element there silicon and oxygen, the formula SiO2. Another example is limestone. Limestone, aliphatic name calcium tricarbonate 4. The element there are calcium, carbon, and oxygen. Another compound example is ethanol. Ethanol, and the formula is C2H5OH. The element there are carbon, hydrogen, and oxygen. Another example of compound is glucose. Glucose, and the formula is C6H12O6. C6H12O6. The elements in glucose are carbon, hydrogen, and oxygen. The last example under this, soap. The elements we have in soap are sodium, carbon, hydrogen, and oxygen. And the formula here is C17H25COONA. So once again, a compound form when two or more elements are combined chemically. So compound form from a chemical reaction or as a product of chemical change. Let's go to the third category now, the third group, when you want to classify matter chemically, mixtures. Mixture contain two or more constituents which can easily be separated by physical method. A mixture contains two or more constituents which can easily be separated by physical means or by physical method. Examples of mixtures are urine. Urine is a mixture, while urea is a compound. Another example of mixture is blood. Blood, because blood contains white blood cell, red blood cell, plasma, and platelets. So blood is a mixture. Also, the third example is petroleum or crude oil. Petroleum or crude oil, which can be separated into different fractions, which are petrol, diesel, engine oil, etc. And the third example here is milk. So these are example of mixture. Now you have type of mixture. Mixture can either be homogeneous mixture or heterogeneous mixture. Homogeneous mixture is a mixture in which all the constituents are in the same state throughout, in the same state. That is solid, if they are solid all together. If they are in liquid, all of them will be in the liquid state or in gaseous state, as the case may be. For example, when you have sugar and salt, it can be example homogeneous mixture. That is, the two are in the solid state. A homogeneous mixture is a mixture all the constituents are in the same state, in the same state. That is, they are uniform, and the particles there are not noticeable to the naked eyes. For example, sugar and salt solution. If you put sugar, you can see that even the color appears similar, and even the two will dissolve in water. So the second one is referred to as heterogeneous mixture.